Hello, we are Team SOS and we are working on the DNS. Allow me to present our team member and their duties. First, Guy will explain the fundamentals of DNS. Matt will then demonstrate how DNS works. Afterwards, Hammer will walk you through the DNS iterative process step by step. Finally, Tay will give a summary of what we have talked about.
So first, the introduction. Humans can be identified in a variety of ways. For example, we can be recognized by names like Matt and Hammer. On the other hand, computers do not refer to each other by their names. Instead, they refer to each other by set of number, which is IP addresses. Because that is how computers communicate over network.
In order to reconcile these preferences for the computer, we need a directory service to translate the domain name into IP address. This is the main task of the DNS, or the Internet Domain Name System. DNS is located in the application layer protocol, which allows the host to query the database. DNS commonly cooperates with other application layer protocol such as HTTP and STMP to translate the human language into computer language. If you want to go to a certain website, for example, let's use google.com. Now technically you don't need to type in google.com, but if you already know the IP address of the Google web page. But we humans do not accustomed to memorizing all the IP address. That's why we can use the DNS to translate the domain name into the IP address. The user machine will run the client side of the DNS application, which later will be sent to a query containing the hostname to a DNS server. The DNS client eventually retrieves a reply, which includes the IP address for the hostname. Once the process is done, then the computer will be able to communicate with a Google web server and retrieve the web page.
So, as we can see, the host first sends a DNS query message to its local DNS server. The query message contains the hostname to be translated. Then, the local DNS server forwards the query message to a root DNS server. The root DNS server then takes notes of the suffix and returns to the local DNS server a list of IP addresses for TLD servers. After that, the local DNS server then resends the query message to one of these TLD servers. The TLD servers take notes of the suffix and responds with the IP address of the authoritative DNS server. Finally, the local DNS server resends the query message, which responds with the IP address. Note that in this example, in order to obtain the mapping for one hostname, 8 DNS messages were sent, 4 query message and 4 reply messages.
Now if you're wondering what root name DNS server is, root name DNS server provides the IP address of the TLD server, and there are over 400 root name servers scattered all over the world. And for the top level domain server, or the TLD, it is responsible for keeping the information for the top level domain such as .com, .org, and .net. The TLD server provides the IP address for the authoritative DNS server.
An authoritative DNS server is a server that only gives an answer to DNS queries from data that has been configured by an original source.
In conclusion, DNS, or the domain name system, is a database that helps to locate and translate internet domain names into various IP addresses. Similar to how phone match a name to a phone number, most online activities rely on DNS to find an IP address and connect to the internet quickly. A domain name might correspond to more than one IP address, since many people can look for the same website at the same time. For instance, if more than one people search for YouTube, each of them will obtain a separate unique IP address from different servers. Otherwise, if a domain name only had one server and IP address, those people would have to wait too long. Thank you for your time.